Alright, let's move directly to the characteristics of covalent combination. Characteristics of covalent, ordinary covalent compounds that are formed at the end of covalent combination. We said since molecules are produced at the end of the reaction, they do not conduct electricity. They do not conduct electricity. We said too, since molecules are formed at the end of the reaction, they have a definite shape. They have a definite shape. Since molecules are formed at the end of this reaction, they form a definite shape. The other one, we said they dissolve only in organic solvent like benzene. They dissolve, or they are soluble in a what? Inorganic solvent. A very good organic solvent is chloroform. Chloroform is a very good example of organic solvent. So in this now we have said that in ordinary covalent bonding, we say the participating chemical element, they contribute this electron equally. So when they contribute this electron equally, they give birth to a more stable compounds. A very good example is the formation of hydrogen molecule, formation of water molecule, formation of chlorine molecule. In all of these, there's a sharing of this electron between this participating chemical element, and this electron are shared equally. So this takes us to the next subtopic known as coordinate covalent bonding or dative bonding. Coordinate covalent combination of bonding or dative, it's also known as dative bonding. So in this aspect, this is opposite of ordinary covalent combination. In this aspect, one of these electron is contributed by one participating chemical element. That is, for instance, if we should say A, the B, only the electron that is used for this chemical bonding is contributed by one participating chemical element. And this participating chemical element must have a lone pair. As I've said, a lone pair is that electron that do not participate in the existing chemical bonding. So that is to say, a very good example of compounds that have a lone pair, we have water. And ammonia. Ammonia have a lone pair. That is to say, if we should react an HCl in these three guys, one of the hydrogen ion from HCl will attach to these molecules. So in this aspect, a very good example of this coordinate covalent combination is the formation of ozonium ion. Ozonium ion, that is to say H3 plus. So in this aspect, one of the hydrogen from an acid, let's use a monobasic acid like HCl. One of the acid from an acid is here. So without no electron, when it reacts with water, we say water, we have oxygen is 2, we have 6. We have 6 electrons in the outermost shell. We said 2 molecules of water. We said H is attached to this, H is attached to this. We said we have 2 lone pair of electrons. So by so doing, this reaction will give birth to what is known as ozonium ion. That is to say, we are going to have this, one of the electrons from the oxygen atom, from the hydrogen atom, they come together. So one of these hydrogen ion become attached to to this lone pairs. So in this aspect, ozonium ion is formed. Ozonium ion is formed. Ozonium ion is formed at the end. That is to say, for any chemical compound, chemical element to undergo coordinates covalent, the participating species or chemical element must have a lone pair. A very good example of compounds that have a lone pair, we have the water and the oxygen molecule, and this ammonia molecule. So in this now, we said for a coordinate covalent, one of the participating chemical element must have a lone pair. We said a lone pair are those existing electron, are these electrons that do not participate in the existing bond. That is to say, in this aspect, this ozonium ion is obtained when this hydrogen ion from an acid got attached to this lone pair to give ozonium ion. And this coordinate covalent combination, they share characteristics. They have similar characteristics with the ordinary covalent compounds, just that these coordinate compound, they are less volatile. So in this aspect, you are going to move directly to what is known as other binding forces in chemical combination. Other binding forces, we have one of them is we have Van der Waals forces. Van der Waals will talk about metallic bonding. This exists between metals. The external electrons try to exert a pressure on the nucleus. So by so doing, they undergo what is known as metallic bonding. So we're going to talk about more about this hydrogen bonding. So let's emphasize on this hydrogen bonding because it's very common as well. In this aspect, when hydrogen bonding occurs, when hydrogen is covalently linked to atoms such as nitrogen, when it is covalently linked to nitrogen, when it is linked to oxygen, when it's linked to fluorine. So in this aspect, when hydrogen is covalently linked with this nitrogen, oxygen, and fluorine, they undergo what is known as hydrogen bonding. That is to say, hydrogen bonding is an intermolecular force that exists when hydrogen is covalently linked to these more electronegative atoms. For instance, let's use hydrogen. For instance, is linked to something like fluorine that is more electronegative. What happened here is that this shared electron they share together. This, because of the high electronegativity of this fluorine will tend to pull this shared electron to itself. When it pulls this electron to itself, if it makes this hydrogen atom to be partially positive, while this become partially negative. By so doing, what we know as dipole is formed in this process. So when this dipole is formed within this process due to the pulling of this electron from this hydrogen atom, because this atom here is more electronegative, it gives birth to a dipole. When the opposite dipoles and this opposite dipole of each of these atoms, they attract each other. This force of attraction, this electrostatic force of attraction, gave birth to what is known as hydrogen bonding. That is to say, hydrogen bonding will exist when hydrogen is attached to a more electronegative element like nitrogen, oxygen, and fluorine. So in this aspect, this more electronegative element, this shared electron they share together, is that more of this electron is pulled by the more electronegative atom. By so doing, making this hydrogen atom to be less to be partially positive. By so doing, this more electronegative atom becomes what? Partially negative. By so doing, dipole is formed. So when the opposite each of these dipoles, they come together, there's a force of attraction between two of them. This force of attraction, this intermolecular force of attraction, is formed by what? It's known as what? Hydrogen bonding. So by so doing, this is all about chemical combination. So in our lessons, we talked about electrovalent bonding, we talk about covalent bonding, we talk about types of covalent bonding. We also talk about some bonding forces in a given compound. Let's recap. We said electrovalent compound, there is a transfer of electron from a metal to a non-metal. A very good example is the formation of sodium chloride. In coordinate covalent, the ordinary coordinate covalent, these shared electron, they are shared equally by this participating chemical element. By so doing, they share this electron to become stable. But in a coordinate covalent bonding, known as dative bonding, in this aspect, one of these participating species is the one bringing out this electron for bonding. That is to say, this such element must have a lone pair. As I've explained, what is known as a lone pair. A lone pair is that bond that is in a compound that do not participate to this existing chemical combination, like oxygen. Oxygen have two lone pair. So when you react with any of these atoms, one of these lone pair is used for bonding. Thank you very much. Please, if you like this video, do well to subscribe to